All right, guys. So I already showed you four different ways or shortcuts of figuring out how triangles are congruent. So now we're going to move on to the fifth way. And it actually is very specific. It's only to right triangles. So I wanted to show you real quick a right triangle and all the different parts, okay? First of all, you know it's a right triangle when it has a 90 degree, okay? And it'll either be marked 90 degrees or by the little box, okay? Remember, I'm not using a ruler. I'm just kind of freehanding them. So I apologize in advance if my lines are not straight. Okay, but here it is. All right. A right triangle consists of two legs. That's what the sides are called. And then the hypotenuse. Hypotenuse will always be the longest side of the right triangle. And it's always right across from the 90 degrees. So remember that. It's a leg, and a hypotenuse. Okay. All right. Now let's take a look at the theorem. All right, so the theorem we're going to talk about is called the hypotenuse leg congruence theorem, or HL. Okay, that's kind of short for that. So let me show you what the picture looks like. So here I have two triangles, triangle ABC and triangle DF. All right, according to the picture, we know they're both right triangles. Right? How? Remember, they both have right angles. And then what's given to us? Side BC is congruent to side EF. Those are legs, okay? And side AC is congruent to side DF, and those are hypotenuse. Okay, so why are these two triangles congruent? Because of the HL theorem, okay? This would be the hypotenuse, this would be the leg, okay? So HL. And again, HL only gets used for right triangles. So now let's look at our congruency theorem. Okay. So if leg BC is congruent to leg EF and hypotenuse AC is congruent to hypotenuse DF, then triangle ABC, then triangle ABC is congruent to triangle DF. And that's it. So let's take a look at some examples, okay? Okay, I'm going to use these three examples. So it says, determine whether you are given enough information to prove that the triangles are congruent. Explain your answer. So let's start with number 5. Okay, so we're going to redraw it and work off of that. Okay, so here it is. I went ahead and redrew it already. So here we have a quadrilateral, but within this quadrilateral, we have two right triangles, okay? So look, right away, I know what's given is side MN and side PQ are congruent. So I have that. Okay, so again, like always, you're going to ask yourself, what else can you prove to be congruent? Can you prove any other sides, any other angles? And right away, I can see the most obvious. Remember, they're sharing a side. Which side? MQ. Oh my gosh, my line looks very not so straight. Again, I'm not using a ruler. I apologize. Just assume the lines are straight. So I would say line MQ is congruent to line MQ. And do you remember the reason? Remember, this reason gets used a lot. So this is the only thing that's given. So I could say MQ, and I'm going to write this in blue. MQ is congruent to MQ itself. So that would be by reflexive property. Okay? Remember, that one gets used a lot. So again, if I were to take these two triangles apart, we would have two right triangles. Well, what is this of a right triangle? That's the leg. That's a leg. And this would be the hypotenuse. So these two triangles are congruent by HL, hypotenuse leg theorem. So let's see what the congruency statement looks like. All right, I apologize if my writing is getting messier. Okay, so we said the sides were given were congruent, then we came up with that by reflexive. So I could say triangle MNQ is congruent to triangle QPM. Remember, order matters by HL theorem. Okay, so these triangles are congruent. All right, let's go to the next one. All right, the next one looks like this. And you know what? I'm not even going to bother redrawing it. We have two triangles. They're not right triangles, but it doesn't matter. And if you look here, all three angles are congruent to each other. And guess what? We don't have a theorem that says angle, angle, angle. That would be triple A. There's no triple A, okay? That's what your parents have. So There's no such thing. There's no theorem that proves these two triangles are congruent. So we're not even going to bother drawing it. It's just not enough information. Okay. You cannot prove those two triangles are congruent. So that means we're going to move on to number 7. Okay. And guess what? Same thing. I'm not even going to bother drawing this one because this one has all 3 sides congruent. This one doesn't have all 3 sides congruent. Okay. So, this one would be considered an equilateral, and I know if it's an equilateral, all 3 angles are congruent. I know that this would be 60 60 60 because all the angles would also be congruent. For equilateral, they're also equal angular. Over here we have 2 angles congruent, which then means this side would be congruent. But the thing is, I don't know if the third side is congruent, and I have no idea if the third angle would be congruent because there's just not enough information. So I don't have to draw these, okay? There's just not enough information. So these would not be considered congruent, okay? All right. So out of the 3 triangles, this was the only one that I was able to prove are congruent, okay? And that was by HL. All right, so now I'm going to have you guys try a few. All right, good luck.